If you are visiting our channel for the first time, please subscribe first to get the basic and advanced maths concepts. Hello everyone. In our today's lecture we are going to learn, or we can say that we are going to prove that under root 3 is an irrational number. So before that we have to look for some points that you need to keep in your mind while proving this, that under root 3 is an irrational number. So point number 1 is, if an integer is divisible by 3, then 3 is a factor of that integer. Point number 2 is, rational number can be simplified and expressed in simplest form. For example, 3 over 6 can be simplified to 1 over 2. Then the fact number 3 is, it is impossible to simplify a rational number indefinitely. It means you have to reach a point where you have to stop simplifying the rational number and you get a number that where you will say yes, this is the number, and this is the number where you cannot simplify it further and it is irreducible. So we came to a point where p and q, that is numerator and denominator, would become co-prime. So these are the 3 points that you have to keep in your mind regarding rational number. So we will start its proof by contradiction. Now what is meant by contradiction? In proof by contradiction, contrary is assumed to be true. Now what is contrary? As we have to prove that under root 3 is irrational. So in proof by contradiction, we have to assume an opposite condition or opposite statement, that is, we have to prove that under root 3 is rational. So this is called the proof by contradiction. So we have to suppose what? Suppose under root 3 is rational. So according to the definition of rational numbers, a rational number is a number that can be written in the form of p over q. So we have to equate under root 3 with p over q. So under root 3 is rational, so I'll write under root 3 is equals to p over q, where p and q are any integers and q should not be equal to 0, and we are also assuming here that p and q both are irreducible. P over q are both irreducible, or you can say they are co-prime because they have no common factor other than 1. So we are assuming that p over q are in such a form. So we have to take the square on both sides, due to which the square root will be cancelled out and we will get p square over q square. And if we multiply q square on both sides, what we will get? We will get 3q square is equals to p square. Now this is equation number 1. Now we have to deduce some facts from this. It means that p square is divisible by 3. That you can divide the p square by 3. So if p square is divisible by 3, then p is also divisible by 3. So it means, so as p is also divisible by 3, so according to our rule number 1, that if an integer is divisible by 3, then 3 is a factor of that integer. So this implies that 3 is a factor of p, and we can write it as p is equals to 3k. K is any integer. So we have to put this value of p in this equation 1. What it will be then? 3q square is equals to 3k whole square. 3q square is equals to 9k square. So if we divide 3 on both sides, we will get q square is equals to 3k square. So what does it mean? This is equation number 2. So from equation 2, we have deduced that q square is divisible by 3. As in equation 1, p square was divisible by 3. So this implies that q is also divisible by 3, which means 3 is a factor of q. So we have got 2 equations. Now from 1 and 2, if I write here what are the results. Now carefully looking at from 1 and 2, what we have. We have seen that in equation 1, p is divisible by 3, and in equation 2, q is divisible by 3. This contradicts that p over q is irreducible, as we have written in the assumption in the very start that p and q are irreducible. But here we have got the p and q in a reducible form, in a form that can be reducible, as we have assumed that p and q have no common factors. But from 1 and 2 we have seen that P and Q both have a common factor, that is 3. So from 1 and 2, P and Q have common factor 3. That contradicts that P over Q is irreducible, or P over Q have no common factors. So we can say that under root 3 is irrational, because what we have assumed is not proved at the end. So this is the proof by contradiction, where contrary is assumed to be true at the start of the proof, and after the logical reasoning, assumption is shown not to be true. So our assumption that P over Q is irreducible is not true, and our assumption that under root 3 is rational is not true, and we have proved it through logical reasoning that under root 3 is irrational. So that's all from today's lecture. Thank you. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.